Hello guys, welcome back to Maths on African Motives. We are still on our integration. We talked about the integration part. On the introduction, we had our introduction. It talked with different types of integrals, talking about the integral of tan, the integral of cos, the integral of sine, and a combination of a sine and a cos. So in this case, we shall be checking looking into the integral of a tan and a cot separated, all right, being raised to a certain exponent. Let's say tan to the exponent of 4 to the exponent of 5. So this n in this case can be an odd number, or this n can be an even number. So for this part, for a tan and a cot, whether we are working with this to be an even or to be an odd, we are going to be using these identities from the tan squared. From the tan squared ax, we know that the tan squared of ax is equal to sec squared ax minus 1, and also cot squared of ax is equal to cosec squared of ax minus 1. This is what we know. So we are going to apply these identities, whether it's to the exponent of 5, to the whatever power that you're given. That's why I said for both, you're going to use these identities. And also, you are going to use, you replace them, try by all means to replace stage by stage, all right? Then you use your algebraic substitution method in the integrals, all right? So this is the straightforward thing that we have. So I'm going to show you how do you work out these as we are attempting persons, so that you'll be able to attempt any person, because these are like follow-up stages that you need to understand, that you need to follow, all right? So let's say we are given tan to the exponent of 4. We are given to integrate, let's say the first equation that we want to integrate is of tan. And we want to integrate tan to the exponent of 4 of 4x with respect to x. Okay. So like I said, we are using the two identities. So of the two identities, there's no way I'm going to think about one of cot, because I'm given a tan. So I'm supposed to think of the identity of what? A tan. And on those identities, it is tan squared of ax, which is equal to the sec squared of ax minus 1. If we are to take a closer look, it means that whatever that I'm going to do here, it must be written in terms of tan squared. It must be written in terms of what? In terms of tan squared. So how can we expand tan to the exponent of 4 in terms of tan squared? All right, this is what you're going to have. This is going to give us tan, the integral of tan to the exponent of 2 of 4x, which is this one. If you consider the previous question that we had to square this so that it gives us a 4. But this time, no, guys. For tan and for cot, you do not square. You multiply by tan again. You are going to see this so that you can use your substitution method properly. This and this add together to give us what? To give us a 4. So meaning to say we still have what we want, which is the tan. So as we need to substitute the tan squared with the equivalent identity for tan, which is sec squared. So if we substitute this with the equivalent identity, we are going to obtain sec squared 4x minus 1 multiplied to this tan squared. So it's going to be multiplied to tan squared 4x dx like this. Okay. So like I said, it's going to be easier for our substitution method. Why? Because we can expand this back. If we expand this, we are going to obtain the integral of sec squared 4x times tan, which is tan squared 4x with respect to x. All right, minus 1 times tan, so it's going to be minus the integral of tan. So it's going to be the integral of tan 4x dx like that. Okay. So what you notice is that on this part, we can apply the substitution method. Like I said, you're going to end up with a condition where you need to use your substitution. So on this part, you're going to use your substitution method. But here you are going to use direct your formula sheet because we are given the integral of tan. We have this integral of tan from our formula sheet, tan squared. All right. So in order for us to use substitution, we need something that is going to cancel. So we can choose u to be a tan so that we get sec squared, and sec squared will cancel with this sec squared. So if we choose our u to be tan squared, tan 4x, the derivative of u with respect to x for tan is going to be 4 sec squared 4x. Then we make dx the subject, so it is going to be du over 4 sec squared 4x. All right, so that means if we were to substitute properly here, this was going to cancel the sec squared and the sec squared because this is in the denominator. So you are going to remain with 1 over 4 since this is in the denominator, same as 1 over 4. So this is going to give us 1 over 4. The integral of sec squared cancelled with this sec squared 4x. So we are going to be left with tan squared 4x, of which tan is represented by u. So it's going to be the integral of u squared, since this is tan squared. So it's going to be u squared with respect to what? With respect to u. All right, so guys, just revise again your substitution method, all right? Your substitution method from your N5, okay? You substitute back there, that cancels, you take it outside and so forth. All right, so you're going to integrate this. Let us just write minus the integral of tan squared 4x with respect to x. So let us integrate and see what you're going to have. U squared with respect to u, we are going to add 1. So that is going to be u to the exponent of 3 over 3. All right, minus, like I said, the integral of tan, we are given this in our formula sheet. So if we check, let's just hope I kept that part for tan. Let's just hope so. All right, here we have it here. If we check on these integrals on this part, we are given the integral of tan here. These are the integrals, tan squared ax, which is going to give us 1 over a tan ax minus x. So this is how you integrate a tan squared. So there's no need for you to use any substitution for there. All right, so we saw that the integral of a tan, if it is tan ax like this with respect to x, that is the most important, it's ax here. All right, and this is a squared, tan squared like that. It is going to give us 1 over a tan ax. All right, tan ax minus x plus c. This is what we get. So if we are to do this, this is our a. Our a in this case is this number here, which is 4. So meaning to say, we are going to get 1 over a, which is 1 over 4 in that case from this 1 over tan. All right, so we are getting this from 1 over tan. So it's going to be 1 over 4. So that is 1 over 4 tan ax, which is tan ax as it is, which is tan 4x as it is. All right, minus x. All right, so here we are going to have a minus x. All right, plus the constant of integration. So that's it. So on this side, we just gonna substitute. Remember, u was what? U was tan. Tan, u was equal to tan 4x. So where we see a u here, we're gonna substitute tan. So it's going to be 1 over 4 times 1 over 3, which is 1 over 12. Tan, remember we said this is tan 4x. So it's gonna be tan to the exponent of 3 of 4x. All right, here we expand by negative throughout the brackets. It's going to be negative times 1 over 4, which is negative 1 over 4. You can even leave it like that. You can even leave it like that, all right? So this will be 1 over 4 tan 4x. Minus and minus here is going to be a plus. So that will be plus x, plus the constant of integration. All right, so that is how we can integrate such integrals, okay? Such integrals for tan, for cot to the exponent of 4 to the exponent of 5. You just have to expand until you have what can be integrated, all right? Some of these integrals, like I said, you have them in your formula sheet. The integral for tan, the integral for cot, they are there. Cot squared, the integral of tan squared, they are there in the formula sheet. So the procedure there is that you have to expand the first part, expand properly. Use your substitution method where it is appropriate. Where it is not appropriate, where you are given the integrals, you use your integrals as they are. Because it's not like substitution method is always appropriate. Some is not even appropriate. You have to apply your integrals. So where you are supposed to use your basic integrals, you apply your basic integrals like this part for tan squared. You're going to apply your basic integrals for that tan squared. So that is how your questions might be given in terms of a tan, and you, with the use of the formula sheet, it helps you to answer any other question that can be applied. Let us check what we have for cot. So it's still one and the same thing. Like I said, these identities are still, we still use the same identities for both cot and for tan. So let us say we've got the integral of cot to the exponent of 5 of 3x with respect to x. Okay. So how can we integrate this? So the cot, if we are to simplify further, remember what we need is to have a cot squared. So we need a cot squared, and we know that the cot squared of 3x is supposed to be equivalent to the cosec squared of 3x minus 1. So we are supposed to expand until we see this cot squared. So how can we expand it from the cot to the exponent of 5? All right. Let's say we expand it this way. We say this is cot squared to the exponent of 3. But because you are going to, because this one, I want you to be careful. This cot squared here is going to be replaced with a cosec squared. So it is going to be wise enough that we write the other part as it is for cot. So it is going to be cot to the exponent of 3 of 3x, so that if we add 2 and 3, we get a 5. So like I said, because this one is going to be substituted with what? With a cosec squared, this one that we have here, it is going to be so meaning to say it's best for you to leave this as it is. Why leaving it as it is? Because you are simply going to substitute, you are going to have it as your substitution now. Let u be equal to cot. So that is why I'm saying you must keep this. So each and every integral has got its own advantages that you need to be in mind and so forth. All right, so let us get this into consideration. So this cot, like I said, is going to change into cosec squared. So we're going to have this as cosec squared. So it is going to be cosec squared 3x minus 1 times cot cubed 3x with respect to x here. Then we instead of using substitution, because there is a minus 1, so we have to expand so that we see if this is going to work. So we expand it throughout. So let us multiply throughout. It's going to be the integral of cosec squared 3x times cot. So this will be cot to the exponent of 3, 3x like that with respect to x. We multiply minus 1 and this on its own. So it's minus the integral of cot to the exponent of 3 of 3x. All right. So this will be of 3x with respect to x like that. Okay. Now I want you to be careful here. I want you to see something. This was a 5. We expanded, we have this, that where we can use substitution, yes, we can apply our substitution method. But I want you to see what is happening here. It's different from the previous question. The previous question, we were left with cot squared, and cot squared, we're able to integrate that direct because it is there from our formula sheet. But for cot to the exponent of 3, we cannot integrate this. We can't integrate this direct. So what do we do? It's like another question on its own, this one. Just take this one. They can ask you to integrate this on its own, this one. So we are back again to the expansion, expanding in terms of cot squared in this manner that we used before. They can ask you a question like this in a normal examination. You use the same way that we applied. So meaning to say, we are going to consider or have the same simplification. How can we expand this in terms of cot squared? So meaning to say, we are going to have in terms of cot squared, this one, let us just write as it is this one. So you're going to have cosec squared 3x times cot cubed 3x with respect to x minus, we expand cot. So this will be cot squared 3x times cot 3x, so that it gives us what? A 3. This one and this one add up to 3. So we are back again to that cot squared, the one that we had here before. The one that we, let me do this so that I do not confuse you here. The one that we wrote here before, cot squared, in a manner that we can substitute it. So now we have it. We substitute again, just like the previous case. So this is what you're going to have. So we are going to have this one. I'm just going to write as it is, cosec squared. So this will be cosec squared 3x cot cubed 3x with respect to x minus this one. We said is going to be, we substitute the equivalent of cot squared, just like what we did on this part. We substitute the equivalent, which is cosec squared 3x minus 1 times this cot 3x that we have. Okay, we have a respect to x there, guys. All right. So this is cot 3x with respect to x. So that is what we have for that part. So just like what we did on this part, when we introduced this, we had to multiply by this dx, expanding the bracket so that we can integrate each separate. This is exactly the same thing that we are going to do, just like the previous part. So this, just write as it is, the integral of cosec squared 3x cot cubed 3x with respect to x minus, so this is a minus, we multiply this and this together. So it's going to be minus the integral of cosec squared 3x cot 3x. So this is cot 3x. So here minus and minus, it's a plus. So it's going to be plus the integral of 1 times cot x. So this is cot 3x, sorry. This is cot 3x with respect to x. So also here with respect to x. So now we are going to integrate this with respect to x. We integrate this with respect to x and also this with respect to x. Everything now can be integrated. So if we check the first part and the second part, there is a need for us to apply the substitution method there. So we can work from cot, because cot can cancel the cosec squared, cot the cosec squared. So we can let our u to be equivalent to cosec, cot 3x. So we find the derivative of u with respect to x. Remember, cot, it gives us a negative cosec, so it's going to be negative 3 cosec squared 3x like this. Then find dx. All right, so that will be minus du over 3 cosec squared. So this will be cosec squared. All right, cosec squared x. All right. Okay, guys, on the numerator, as long as you understand there. Okay, so this is 3x here. Okay. So if we were to take a closer look, we're supposed to bring back this into our normal substitution. But if we get rid of this, we're going to see that the cosec squared and the cosec squared 3x will cancel each other. So you're going to left with minus 1 over 3 out of the integral, right? So that will be minus 1 over 3 out of the integral. Since the cosec and the cosec canceled, that means we are left with cot cubed. And what represents cot? It's u. Remember I said cot is u, so it's u to the exponent of 3 with respect to u, because this one, it is now out of the integral. So you're just left with what? With the du on this side. Okay, we do the same thing because this is to be applied also on this part here. We're supposed to do the same thing. So we multiply negative, negative, just like the previous case, negative 1 over 3 and positive 1, it's going to be positive 1 over 3, the integral of cosec squared, and cosec squared also cancels here. So you are left with cot, whereby cot is represented by u. All right, so we integrate this with respect to u. Then here there's no need for us to use substitute there. We're just gonna integrate direct as it is. So let us just write the integral of cot 3x with respect to x. Okay, so this is it. Let us integrate this part and see what we are going to have here. Minus 1 over 3, the integral of u to the exponent of 3, that's u, to the exponent of 4 over 4, plus 1 over 3, the integral of u, that is going to be, this is a 1, so you're going to add a 1, which is u squared over 2. All right, plus the integral of cot 3x. So for you to integrate cot 3x, you are going to need the formula sheet. All right, we are going to need the formula sheet. Let me see if I have that part. If I don't, then I'm just going to write it down for you guys. I want you to see exactly how you're going to take it from your formula sheet. So from your formula sheet here, let's check if we have a cot down there. There must be a cot here on the integrals. There must be a cot down there. All right, there we have a cot. So this is the integral of a cot. All right. So the integral of a cot ax is 1 over a ln sine ax plus c. All right, so I'm just going to write this so that we properly understand each other. All right, let me do this. Okay, I need that page again. All right, let's just hope I'm gonna see my previous work. I just need that previous work of mine. All right, let me just do this. Maybe, okay, here, oh, it's me who skipped it, is here. All right, no problem. This is what I want here. So like I said, on this part, we are going to have the integral. So I'm just going to write down that integral again so that we properly see what is happening together here. So we said we're given, in fact, the integral. Remember, this is cot. So is the integral of cot ax, if this is ax, with respect to x, we saw the answer, it was given as 1 over a, then ln sine ax, like this, okay, plus the constant of integration. So what does it mean? It means here our a is 3, this is cot ax. So it's going to be 1 over a, so this will be plus 1 over a, which is 1 over 3, ln sine ax. So it's going to be ln sine of ax, which is sine of 3x as it is. So it's going to be sine of 3x. All right, so this is what you're going to have, plus the constant of integration. So that's it. We are done on that part. All right. So the rest here, we are just substituting. Remember our u, we said u is equal to cot. So where there is a u here, we are going to substitute what? Our cot. Wherever there is a u, we're going to put back our cot. So this is be minus 1 over 3 times 1 over 4. The 4 is in the denominator, so it's 1 over 4. So it's going to be minus 1 over 12. So that will be minus 1 over 12. Remember, u is cot. So this will be cot to the exponent of 4. All right, of what? Of 3x. Okay, so this is what we have on this part. We do the same thing on this part here. Again, u, we substitute cot, but this is 1 over 3 times 1 over 2. The 2 is in the denominator, so it's same as 1 over 2. So if you multiply 1 over 2 and 1 over 3 together, you get 1 over 6. So this is 1 over 6. In place of u, we substitute cot 3x. So this is going to be cot to the exponent of 2, all right, of this 3x. Then the rest, it just remains as it is, 1 over 3. So this is just 1 over 3, the ln of sine 3x. So this is the ln of sine 3x, like this, plus the constant of integration. So that is how we could have integrated this part. So it is a matter of fact that you are supposed to be very, very careful in your integrals. How do you integrate the given integrals on the court or for tan? And sometimes they can give us a combination of both. You just have to be careful. How do you simplify? Which identity is it that you're supposed to take or that you're supposed to use? But as you can see, it's a straightforward thing that you just need to follow up. It's like a follow-up strategy. Once you work with one person, try another person of the similar nature. You'll see that it's exactly one and the same thing. And also, there are different methods that you can use, but you have to expand. That is the part of cot on and tan. You expand and expand and expand until you have something that is in simplest. Once you have something in simplest form integrated, that's like you wait until do not integrate, and you end up in confusion. Wait up to the last stage where everything can be integrated. When everything can be integrated, then you integrate. That is how you play around with this type of a question. So these are the typical questions that you might have. It just depends with the question that you're given. All right, we can have something like this. Okay, I just want to make something here. The integral of tan to the exponent of 3x and also sec x. Yes, they can do this. If you check here, they did an expansion on the other part, which is fine. But as we are supposed to focus on this tan, this one, that's our major focus there, the tan. So, and we remember we are supposed to write this as tan squared of x is equal to sec squared x minus 1. So to have tan squared, it means we have to expand this as tan squared of x times tan x. If we multiply this, we get tan cubed, all right, times the sec of x that is already there with respect to x. So it is just like the previous case, because here we're just going to take what is equivalent for tan squared x, which is sec squared x minus 1. So this is going to be sec squared x minus 1 like this, all right, for tan squared x. So this part is going to remain as it is, which is tan x times sec x dx like this. All right. So now let us multiply everything here. So if we multiply here, the sec squared and the sec is going to be sec to the exponent of 3. So that will be sec to the exponent of 3x tan x. So we've got tan x there with respect to x, okay? Minus 1 multiplies this part as it is. So it's minus the integral of this part as it is. So that is the negative tan, the integral of tan x sec x dx like this. All right. All right. There is where we are. So the question that you're asking yourself is, how can we be able to integrate now from here? How can we integrate from here? How? Okay, let's consider a situation where, remember on your derivatives, if you differentiate a sec, it gives us sec tan. All right, that will be sec tan. I don't know if we are together there. So meaning to say that we can choose this here. Okay, guys, on this one, you see, I'm trying like to find a way that you can understand me. Okay, you understand me. Let me do this. Here you understand me one way or the other. Okay. If you differentiate a tan, it gives us sec squared. Okay. So it's difficult for you to cancel all the sec because there's sec x here, right? Here there's sec cubed. So it's difficult. But if you differentiate a sec, we know that a sec x, it gives us sec x tan x. So there's a possibility of canceling sec x tan x. All right, there's a possibility of us canceling the sec tan, where there is what? Where there is sec. But is it going to be possible throughout? That is the question. Is it going to be possible throughout? Is it going to be possible throughout? Let's see this. On this part, because we need sec x tan x, here we are going to remain with sec x. For us to have sec x tan x, we are going to write it this way. I want you to see, because we want sec x tan x. I'm coming there. Let's hope you guys, you understand me here. So you're going to have sec squared x like this. Then we just write our sec x tan x aside. So this will be sec x tan x aside. We haven't changed anything because sec x times this, it gives us what? It gives us sec cubed tan x. So we haven't changed anything, all right? Minus the integral of tan x times sec x dx like this. All right. So if we let u to be sec, like what I said here, that we can differentiate sec and it can give us a magic later on. So if we let u to be sec x like this, that means du dx is gonna be sec x tan x, whereby dx, if we make dx the subject, dx, we are going to have du over sec x tan x like this. Okay. This is what we have, guys. This is what we have here. And like I said, I'm just sensing to say, I'm just hoping to say what is in my heart, let it be also in yours, so that we will be together on the same page. Okay, no problem. I just hope you understand me. This is what I was trying to explain here. If we are to substitute back, we are going to see that sec squared, there's nothing that's gonna be able to substitute this. We're gonna use u because sec is u. So this will be the integral of u squared. Then the moment that we want to substitute the dx, it is du over sec x tan x. So the sec x tan x will cancel. That part will cancel. So meaning to say we're just going to be left with u squared with respect to u. Take note, guys, here it will cancel, all right? This part will cancel. So you'll be left with du like that. Minus, I want you to see on this one now. This one is the most complicated one. Because on this one, if we were to substitute, this was going to happen. The tan and the tan, because we are substituting. Remember, we said u is what? U is sec x. Okay. So if we say u is sec x, okay, if we say u is sec x, it's not going to make sense. If we put u is here to say, okay, u is sec x, it's not going to make sense. Okay? Because the dx on this part, I want you to see, the dx on this part is supposed to be given as du over sec x tan x. So the tan x and the tan x was going to cancel. But you'll be left with this sec x. But guys, what is sec x? Sec x, it's u. So where I see this sec x, I see a u, and I see the same u here is the same. So this and this will cancel. So it is the same as what we saw and what we saw. It was just the same. So instead, what could I have done? I could have done this way. Instead of me substituting this as u, I was just, okay, since I can see that this dx here and here, you have got something that I want, I'm just going to substitute only dx. Dx here is equal to what? It is equal to du over sec x tan x. And this is what we have. Sec x and sec x cancel, tan x and tan x cancels. You remain with the 1. That is what we were just supposed to have it done in actual sense. So we are going to be left with the 1, the integral of u. So that is the way that I was. Let me try to explain. I don't know if we are together. I just hope we're going to have another question similar to this so that you properly understand me. But I just hope as I tried to explain what I have. All right, let us integrate this. U to the exponent of 3 over 3 minus 1 with respect to u is going to be a u plus the constant of integration. So that's it. Remember, u was equal to what? We introduced u before. We said u is equal to sec x. So where we see a u, we are going to substitute sec x. So this is going to be sec x. So that is sec to the exponent of 3 of x over 3 minus u, which is sec x. So this is sec x plus the constant of integration. All right, so that is what we are supposed to have at the end of our integral. All right, so there's nothing that we're going to do further. We cannot simplify anything from this part. So you have to be careful, guys. You have to be very, very careful in your simplification. These are the stages. As long as there's a tan, you have to figure out, I have to think of substituting that. But in terms of tan squared, I have to write in terms of tan squared so that I can substitute sec squared minus 1. I can be able to substitute this sec squared minus 1. That is the idea. Once you have that, then play around your substitute, play around with your integral until you get the proper answer. It is similar to this question. Let us have this as our last question. It is the integral of tan. It is similar to that one, tan to the exponent of 4, 3x, but it is different a little bit. Sec squared 3x plus 1 like this. This is what we are given with respect to x. So this one, there's a bracket. So it means we have to think of expanding the bracket then. So let us think of expanding the bracket. So this is it. If we expand this, this is going to be the integral of tan. So this will be tan to the exponent of 4, 3x, and this will be sec squared 3x with respect to x. Tan and 1, we are going to have the integral of tan to the exponent of 4, 3x with respect to x like this. Now, if you consider, there is a question that we did. Actually, we did this question together. I'm trying to figure out that question. All right, we did this question. It was actually of tan. That was our first question. If you still remember, of tan to the exponent of 4 of 3x with this was our first question, if you still remember. So we talked about this integral of a tan. So I'm not going to dwell much on this because we talked about these guys, all right? So I'm not going to dwell much on this part. All right, but here, this one you can just use your substitution is direct. So let us just leave it like that. But here, remember I said for a tan, if it is raised to the exponent of 4, all right, let's see. If our tan is being raised to the exponent of 4 like this, we write it as tan times tan. Like I said, tan is different from what? From our sine and cos. This one, you write it as tan squared 3x times tan squared 3x. Tan squared 3x. Whereby tan squared 3x, you substitute with the equivalent identity for tan for sec, which we said it's sec squared. So this will be sec squared 3x minus 1 times this tan squared that is outside, tan squared 3x with respect to x. And again, like I said, for tan, don't integrate until the last stage where you can integrate everything. So the rest, write it until the last stage. So this part, yes, we can integrate it, but we're going to write it until the last stage. So this is the integral of tan to the exponent of 4, 3x sec squared 3x with respect to x. We multiply. So this time is going to be tan multiplying inside of this. So that will be plus here. So it's going to be plus the integral sec and tan. So that will be tan to the exponent of 2, 3x sec squared. So this is sec squared 3x, all right, with respect to x. Minus, plus, and minus, it gives us a minus. This plus here and this minus, it gives us a minus. So it's minus the integral of 1 times tan, which is tan. So this is tan squared 3x with respect to x. So at this stage, we can see that everything that we have here can be integrated. No matter the method that you are using, but everything here can be integrated. Here using our substitution method between these two, we can see that the sec squared can be cancelled from tan if we let u to be equal to tan, because tan can cancel this, because tan is going to be tan sec squared. So it will be the derivative of u with respect to x is equal to 3 sec squared, 3x. So if we make dx the subject, it is going to be du over 3 sec squared 3x. All right, so this is what we're going to have between these two. You are going to substitute tan. Remember, tan is given as u, so it's u to the exponent of 4. The sec squared 3x and the sec squared 3x cancels, so we remain with 1 over 3. So you're going to take 1 over 3 out of the integral with respect to u. Remember, we are substituting dx, okay? Plus here, so you're going to do the same, the 1 over 3 out of the integral. So it's 1 over 3, the integral of tan squared. Tan is u, so it's going to be u squared with respect to u, because the sec squared and the sec squared 3x will cancel each other. So you'll be just left with du in that manner. All right, so this is it here. We can integrate, so let us just write so that we integrate once. So let us just rewrite as it is tan squared 3x with respect to x. So now we're going to integrate each and every part. Remember, I said for tan squared, it's there in your formula sheet. So you're going to integrate, but here you're going to have 1 over 3. You add 1, so that's u to the exponent of 5 over 5, plus 1 over 3, u to the exponent of 3 over 3, minus the integral of tan, okay? Remember that the integral of tan, guys, we talked about this. I'm not going to rewrite this. I'm not going to go back to the formula sheet. I'm just going to write this for you. Remember, we said from the formula sheet, we saw that the integral of tan ax with respect to x like this is equal to 1 over a. So for tan, it's 1 over a ln sec ax. Ln sec ax like this. All right, this is for tan. So meaning to say our a in this case for tan ix, our a is 3. So this is going to be 1 over a, which is 1 over 3. 1 over a here, so it's going to be 1 over 3, our a, which is 3. Then we have got ln sec of ax, our ax, which is 3x. So this is ln sec 3x like this. Okay, so let us just try to do this like this. Okay, plus the constant of integration. So that's it, plus the constant of integration. We are done. So there we can just combine. Remember, u represents tan 3x from this substitution method. Wherever we are using substitution, where there is a u, it represents tan 3x. So meaning to say this will be tan 3x. So you're going to multiply 1 over 3 and 1 over 5, you get 1 over 15 tan to the exponent of 5 of 3x. Remember, u is tan 3x, plus 1 over 3 times 1 over 3, which is 1 over 9. So this will be 1 over 9 tan to the exponent of 3 of what? Of 3x. All right, then this one multiplied by negative here is going to be negative 1 over 3, the ln of sec x. So this one is just going to remain as it is, the ln of sec 3x like this, plus the constant of integration. So this part is going to remain as it is. There's nothing that we can do. We cannot simplify any further from what we have or from what we are given. All right, did I take everything? Did I take everything for this tan, for this integral of a tan? All right, I'm just gonna see if I took everything. All right, that's it. All right, so that's ln like that. All right, so for tan, that's it. That's how you integrate your tan of x. So it's gonna be guys, this is tan squared. I'm giving you guys for tan x. You see, I'm wondering, like, where are we having like this lean side? Guys, very sorry. And I wrote tan ax, not I need tan squared. See, I'm wondering why. Guys, very, very sorry for this. I'm very, very sorry for this. Very so. This is for tan ax. We need tan squared. Tan squared. You see this thing of not giving you the formula sheet now, the disadvantage. And I was saying I'm gonna show you the formula sheet and then all right, let me write this. Tan squared ax with respect to, if it is a squared like this, it is 1 over a tan ax. All right, tan ax like this minus x plus c. So let's correct this. So it was going to be minus here 1 over a. Our a is 3, so it's 1 over 3 tan ax. So this is going to be tan ax as it is, which is tan 3x as it is, minus x plus c. All right, so this is what you're going to get. Then from there, you multiply by the negative. Negative multiplies, yes, so it's going to be negative 1 over 3 tan 3x like this. All right, negative, which is a positive, so it's going to be positive x. All right. All right, this is supposed to be outside. Why am I putting this inside of the bracket, guys? You see this thing? I'm tired now. I can see that I'm tired now. This is the reason. I'm supposed to have your videos very short next time. Very short. All right, I'm just joking, guys. We shall have as much classes as we can so that we prepare ourselves for the exams. So this is it. That is how you're supposed to simplify this. You are supposed to be very careful. As you can see, it's a small mistake. It affects everything, and that's N6. N6, guys, it's like that. So you have to be careful. So you see the advantage of also you yourself to know identities and also your integrals. You can figure out, no, there's a mistake somehow there. Yes, somehow you cannot even tell that there's a mistake. You figure out after you're done, oh, there was a mistake there. It's like that. This is N6, guys. It's not N1 or N2. You have to be very careful, and also to revisit your lower levels, your N2, N3 for the basics of your understanding, so that you equip yourself much better. All right, so that's what we had, guys. We shall see more questions to come.